So in this video, we do a little bit practical things here. We have the data on ROE and the CEO's salary, okay? And what we do, we just replicate what we have learned in the class, right? So we run the regressions, okay? So how can we run the regression? First of all, we can make a scatter plot to show the relationship between ROE and the salary. So I will demonstrate in three software. First of all, this is Excel. I assume most of you are pretty familiar with Excel. Okay, so what we do is choose these two columns and choose Insert, and from here we choose the Scatter plot. Okay, so actually this is not very typical example, but anyway, we will have better examples. But let's start with this one. Okay, so the regression is basically so by the way, the x-axis is the ROE. Okay, this is ROE, and this is the CEO's salary. So this graph basically shows some kind of relationship between ROE and CEO's salary. So we want to find a line that best fit these scatter plots. Right? Basically, we'll find some line in this way or this way that minimize the sum of residual squared. Right? So what we do here, we can right click and choose this add the trend line. Okay? Right click and choose add trend lines. So then it will choose a fitted line of this hold on. Let me redo this. Okay. So right click and add trending line. So it will show the fitted regression line here. So but we don't know the estimated beta 0 hat and beta 1 hat, right? We choose this display equation on chart. Then it gives you the value of this beta 0 hat, which is 963.19, and the beta 1 hat 18.501. It's exactly the same as what we have seen in the class. Right? Moreover, we can also display the R squares here. Okay, if we also click display the R squared, then we get R squared equal to 1.32%, right? 0.0132, which is also exactly what we found in the class. So this is a very simple example of how to find a regression line. How to find the relationship between return on equity and the CEO's salary in Excel. So for Excel, we can do a simple linear regression, and later we can also do multiple linear regression. Okay? But later, when we talk about more advanced models, its ability is rather limited. So and it's actually not very good at dealing with large data set. So this is a useful technique. At least you can do some primary study about on your data set. Okay, if you have some specific question to study. But if you want to implement some advanced techniques, maybe you have resort to professional statistical packages. Okay, so here there are two popular choices. One is called Stata. Okay, let me clear all of this. Right. Don't worry about this. Okay. Um, so let me close this. I don't need to actually close this. Let me do this. Okay. So this is one popular choice, which is called Stata. Okay. Uh, it's very powerful and it solves a lot of problem, implement a lot of econometric analysis. The problem of this software is not free; it's a commercial software, so uh, you have to pay for it. Okay, and it's expensive actually. Um, but anyway, it's still a popular choice. So here, first of all, what we do is import the data. Suppose you have data in Excel format. Okay, you may have data in other saved in other format. Okay, but I think maybe it's most commonly for you to see data sets in Excel spreadsheets. Right? So what we do is import the data. Let's find this data. Okay, and we click here import the first row as variable names. Now we have the data imported to our data, and here if we click this one, we can view all of our data here, ROE and salary. Okay. Now we run the regression. Typically, we see that we regress salary on ROE. So simply we type the simple command reg salary ROE. So basically reg y x. Okay. Then you implement the regression of regress salary on ROE. And here gives you the result. And the coefficient here corresponding to the betas. The coefficient of ROE is the regression coefficient that is beta 1 hat of ROE, right, which is equal to 18.501 as in the on the slides. And this is constant, which means the beta 0 hat equal to 963.19. It's also the same on the slides. And also we can find R squared here, right? Equals 0.0132. Okay. And for the other numbers, I will explain later. Okay. At first, at least you know how to do regression in Stata. Okay. This is Stata. Uh, the other possible alternative is so-called this R and or R Studio. Okay. Uh, so this one is also very powerful, and the good thing that it is free. It's a free software, but the problem is it's a bit difficult to learn because it's looks like typing programs. Okay, it's looks like a programming language, but it's actually much easier than a typical programming language. Okay, so again here we can import the data set from Excel. Right? We import the data set from Excel. Uh, so the example And we again open this uh, first row as names, as variable names. Okay, sheet default. Sometimes you can choose sheet because here we only have sheet one, so we choose default, and we click import here. It will automatically generate commands that import the data. Okay, so now we can click here. We can view the data here. Okay, hourly and salary, and it is saved in a table called example. Okay, so now what we do is we want to run a regression here. We use this LM, stands for linear model. Okay, we use this function to run regressions, and we want to run regression on the regress salary on ROE. Example at salary. So this example at salary basically means that we use the salary variable in the example table as our y, and we use this tilde to separate y and x. Okay? The x is the ROE. Also, the ROE is in the example data set, right? So we have example at ROE. This is dollar sign, by the way. So this is the delta, which is you know, okay, and press enter. Then we get the intercept 963.2 and the which is beta 0 hat and beta 1 hat 18.5. Okay, so if you want to get more information, you can use summary. Summary of use the summary function and put the regression into the summary function. Okay, so here there's a bit more information. Okay, it tells you the beta 0 hat, beta 1 hat, and a bit of more other quantities we can find. For example, r squared here. This is r squared 0.0132, right? And about other quantities I will explain later. Okay, so this is a first example of how to using the software to do to implement regressions. So at the end of the day, that's the most important thing that you need to learn from the class. Okay, the theoretical things are important. It gives you motivations and explain principles of econometrics, and for you to understand the why we are using this specific method to estimate beta 0 hat, beta 1 hat, and so on, right? And also it tells you what are the necessary assumptions guarantees that our method identify a correct quantity, okay, correct number or correct estimates. Okay, so whenever you apply a certain method, you should justify that you are using the correct method to do the estimation. That is basically go over some crucial assumptions of these regression models, whether or not your data satisfy the assumption allows you to correctly use the regression method. Okay, but practically at the end of the day, you are learning about how to actually give your data set, how to run the regression, and you know give me the quantitative answer about your questions. Okay, so Excel, simple and easy, but and intuitive, but its ability is rather limited. But I think maybe it's suffice for at least half of the classes. I mean, you know, half part of the whole course. And for the other part of the course, maybe it's very limited for Excel to do the analysis. So we have to resort to some advanced statistical packages such as Stata and R or RStudio here, for example. Okay. This one is easy to use, but expensive. And this is free, but it's expensive in terms of your investment in learning this software. Okay, but this is expensive in money. Okay, this is the first example of running regressions, and we will see more in the future. And maybe I will recommend you more study materials on these softwares. Okay, don't worry, I will let you know how to, for example, get access to this software and how to do regressions in this software.